All right, this is more practice problems for factoring applications. This says 5.8, but in the newest book, this is section 5.7, factoring practice. The first question says find the length and width of a rectangular room. So these questions are just like the ones in the lecture lesson. We're going to draw a picture. I'm going to start with a rectangle. Okay, this will be the length and the width. We know the area is 16x squared minus 25, so I'm going to put that in here. 16x squared minus 25. And again, if you're trying to find the length and the width when you already know an area, you're going to factor because the area is the length times the width. And when you factor an expression, you get two things multiplied together to make that expression, so you need to factor. This is the difference of squares. In case you didn't recognize it, this would be 4x plus 5 and 4x minus 5. So the length will be the longer one, which is 4x plus 5, and the width will be the shorter, 4x minus 5. In this case, it says the length is the longer and the width is the shorter. Once the width and length are found, find the value of the width and length when x equals 10. So we're just going to substitute 10 into each of these expressions to give these length and width a number value. So that would be 4 times 10 minus 5, or 40 minus 5, which is 35, and 4 times 10 plus 5, so 40 plus 5, which is 45. Now to find the area, we will need to multiply this length times this width. So area will be 35 times 45. That comes out to be 1,575, and that will be square feet for area. Now, we're going to verify that by taking this expression for area and substituting the 10 in here. So that will be 16 times 10 squared minus 25. And don't forget your order of operations tell you to do exponents before multiply. So 10 squared is 100, so this will be 16 times 100 minus 25, or 1600 minus 25, which comes out to be 1,575 square feet. And you're verifying here that you have the right factors because this, figuring the area this way, comes out to be the same as figuring the area this way. So you have the right factors. All right, on number 2, find the length and width of a square room whose area is 4x squared plus 20x plus 25. Draw a picture. So this is a square room. That's close to a square, whose area is 4x squared plus 20x plus 25. The length and the width are identical because this is a square. So even though this says the length is the longer side and the width is the shorter side, this is a phrase that really we don't need because this is a square. There is no longer and shorter side. But to find the length and width, we're going to factor. If you remember, this is a perfect square trinomial. So factoring this, we take the square root of the first term, the square root of the last term, and we check them by multiplying them together. 2x times 5 is 10x, and doubling it should give us 20x. Pull down the middle sign and give it a square. So that means we have 2x plus 5 times 2x plus 5. That's what this square means. There's two of these, and one of them is the length and the other one's the width. So both the length and the width are 2x plus 5. All right, now once we've done that, we're going to verify when x equals 4. So substitute a 4 in there. 2 times 4 plus 5, 8 plus 5 is 13. And of course, this is going to come out to be the same thing because they're the same. To find the area, we'll multiply 13 times 13, and that would give us 169. Over here now, we're going to take the area expression and we're going to put x equals 4 into the area expression to verify that they come out to be the same. So 4 times 4 squared plus 20 times 4 plus 25. Don't forget, exponents first before multiply. So 4 squared is 16. So this will be 4 times 16 plus 20 times 4 plus 25. 4 times 16 is 64. 20 times 4 is 80 plus 25. And all of that comes out to be 64. Let's add it over here to the side just to make sure. That comes out to be 169. So we've just verified that we have the right factors. By finding the area this way and this way, they come out to be the same. All right, we're going to do some more divers here. The equation of a person who dives off a 96-foot cliff into a river with an initial velocity of 16 feet per second is h equals negative 16t squared plus 16t plus 96, where t is the time in seconds and h is the height in feet. When will the diver hit the water, or when will h be 0? We're going to substitute 0 in here. And if you watch the lesson, you know it's just a little bit more natural to reverse the sides of the equation and write the 0 on the right instead of on the left. This is the same equation as if I put a 0 here. I just reversed the order and got this. So now we're going to factor. We're going to take out this negative first off, and all three of these terms are divisible by 16. That will give us t squared minus t minus 6. There's no t's here, so this GCF is not going to be part of our solution. We're going to factor this trinomial. That will give us t times t, a minus and a plus. Factors of 6 that subtract to make 1 are 3 and 2. And then we set them both equal to 0. T minus 3 equals 0. That means t will come out to be a positive 3. And t plus 2 equals 0. So t comes out to be a negative 2. In the context of this question, when will the diver hit the water? We're talking about seconds here. How many seconds have passed? A negative 2 seconds does not make sense, so this is rejected as a solution. T equals 3, so the diver will hit the water in 3 seconds. Let's try this one. This is the ball. The equation of the path of a ball thrown in the air at a speed of 16 feet per second is h equals negative 16t squared plus 16t, where t is time in seconds, h is height in feet. When will the ball hit the ground, or when will the height equal 0? And again, I'm going to reverse this. And the only reason I do this is just because it looks a little bit more natural. It looks like the equations we saw before with the 0 on the right side. It means the exact same thing. It just looks more natural, more familiar. So the GCF here, again, taking out the negative, both terms are divisible by 16, and both terms have a t in common. So the GCF this time is negative 16t. And when I divide that out of both terms, I'm left with t minus, not plus, minus 1. Now I'm going to set up both of these factors as equal to 0. So negative 16t equals 0, and t minus 1 equals 0. Solve for t by dividing by this negative 16. So in this instance, t equals 0. In this instance, t equals 1. So we saw this before in the lesson. There's actually 2 times when the ball is at the ground. T equals 0, this is your starting time. And this is also after 1 second the ball will hit the ground again. So we could say t equals 0, or the starting, and then t equals 1 second. So after 1 second has passed. Those are both good answers.